Okay, boys. Good morning to all of you. Let us begin today's class.
So,
Yes, sir.
I hope everyone is present today.
yes, sir.
We are doing the chapter electrolysis, chapter 5 of your
Yes, sir.
syllabus. Today is 25th of May 2021, second period 9:10 a.m. to 9:50 a.m. Today is the second day of this chapter electrolysis. Now, I will just like to recall what we have done in the previous class quickly. Okay. In the previous class, I explained you what is an electrolytic cell. Electrolytic cell. An electrolytic
Non-conducting
cell,
cell.
an electrolytic cell is also called voltaic cell. Now, in an electrolytic cell, we use direct current. We use a direct current to cause a chemical change. Now, with the help of a diagram, I will explain this electrolytic cell once more for the sake of revision because in the previous class, because of the maintenance of the Microsoft Teams software, there was a lot of audibility problem. I hope everyone can hear me very clearly.
Yes, sir.
Now,
So,
Yes, sir.
try to look at the diagram which I am drawing on the screen over here. A container, we can take a container, an empty container, and fill this container with, say, a solution, say, dilute sodium chloride solution. Dilute sodium chloride solution. Now, this dilute sodium chloride solution in a container, this solution will act as the electrolyte. It will act as the electrolyte. Now, in this electrolyte, we put two conducting plates like this. We just immerse them, suspend in the solution, immerse them properly. These plates are conducting. They can be made of graphite or iron. Okay, it should be conducting. Now, the plate which you can see on the left hand side, this plate, it is connected by means of wire, connecting wires. Okay, and it is connected to the battery. It is connected to the battery, but before the battery there is a switch. Okay, there is a key, a battery, DC current battery, plus minus, plus minus. And the other electrode, the right hand side electrode, it is connected to the negative terminal of the battery. Now, the electrode the electrode which is connected to the positive terminal of the battery, it is called anode. It is called anode, and the anode carries a positive charge. It carries a positive charge. Okay. The electrode which is connected to the negative terminal of the battery, it is called cathode. It is called cathode, and it carries a negative charge. Okay. The solution, sodium chloride solution, dilute, it is called the electrolyte. Okay. Now, when I say sodium chloride solution, this sodium chloride solution is a strong electrolyte. So, as soon as it is put in the aqueous medium, it will dissociate almost completely. it will dissociate almost completely to produce ions, and the ions will be like this: sodium ion, the other ion will be chloride ion, and since we are using water to dissolve sodium chloride, so water also gets ionized to give hydrogen ion and hydroxyl ion. Am I clear? Now now these are the ions present in the electrolytic solution, in the electrolyte. Now I am writing only one ion each. I am writing only one ion each in this electrolytic solution, just to explain you all. There are plenty of sodium ions, there are plenty of chloride ions, there are plenty of hydrogen ions, and there are plenty of hydroxyl ions. Now, until and unless the switch is put on, these ions are wandering all over. They don't know where to go. But as soon as I put on the switch, as soon as I put on the switch, the current the current starts to flow from the positive terminal of the battery in this direction towards the left. Current starts to flow in this direction towards the left, in this way. And from the negative terminal of the battery, electrons starts to flow in this direction, like this. So the electrons and the current, they move in opposite directions. They move in opposite directions. So keep in mind over here, electrons come out from the negative terminal of the battery and go to the cathode, and current comes out from the positive terminal of the battery and goes to the anode. So this is one important point to understand over here. Now now the anode, we already know it is now carrying a positive charge because the current is coming to it, and the cathode is carrying a negative charge because all the electrons are coming to it. Electrons, we know they carry negative charges. That's why the cathode acquires a negative charge and the anode acquires a positive charge. Okay. Now these ions, they come to know they are supposed to move in which direction. So the sodium ion is positive, so it goes to the cathode. The hydrogen ion is positive, it goes to the cathode. Whereas the chloride ion and the hydroxyl ion, they go to the anode. So this is the movement which is happening. So remember, cations move towards cathode. Cations carry positive charge, cathode is negative charge. So cations move towards cathode, because we know the law of nature, opposite charges attract. That is why cations which carry positive charge, they move to the cathode. Okay. And on the other side, you can see the negatively charged ions, chloride and hydroxyl, they move to the anode. So here we can write anions move towards towards anode. Anions carry negative charge and the anode is carrying a positive charge. So this is what is happening in an electrolytic cell. The example over here of the electrolyte I've taken is sodium chloride solution. Instead of sodium chloride solution, I can take other solutions also. And the other important thing I would like to remind all of you is that you should know what is anode, you should know what is cathode, you should know what is electrolyte, you should know what is electrolytic cell or a voltaic cell. These are the main important basic principle things to understand. Okay. Now, now moving further in this chapter, my dear boys, I would like to continue to the next slide and explain you some more things based to this chapter. Now, pay attention. Now, the next thing I would like to explain you is something called electrochemical series. Electrochemical series or activity series. Electrochemical series or activity series. Now, My dear boys, when you were in class 8, class 7, or class 8 to be more precise, in class 8 we learned the activity series of metals. We have learned the activity series of metals, isn't it? Activity series of metals. Have you learned
Yes, sir. Yes,
activity
sir.
series of
Yes,
metals?
sir.
Can somebody tell me the elements
Sir,
present in the activity series from top to bottom?
Sir, potassium.
sir, potassium.
Tell me, tell me.
Potassium, K, NaCl, MgA.
Aluminum.
Yeah, tell me. Very good. Who was that? Who was that? Nawang.
Yeah,
Huh?
what's this?
Chawang. Oh, very good. Very good. Very
Soy
good.
one I. Soy one I.
Very good. Yes, Aditya also.
Yes,
So
sir.
this whatever you have spoken, it is called activity series of metals. But today, in this chapter, electrolysis, we'll be learning a similar thing, which is called electrochemical series or activity series. Okay. Now this electrochemical series or activity series, it is a series in which ions are placed arranged in decreasing order of their tendency to lose or gain electrons. Now this is the meaning of electrochemical series. Now let me explain this in much detail. Okay. Now I'll explain you the electrochemical series in much detail. Have a look very carefully. Electrochemical series. Electrochemical series. Now electrochemical series contains ions. Now these are the ions. On the left hand side I'm writing the ions K, Ca, Na, KNaCa, Mg, Al, Zn, Fe, Pb, H, Cu, Hg, Ag,
Okay.
Au, and Pt. Okay. Now these are all ions, so I have to put their charges valencies plus 2, plus 1, plus 2, plus 3, plus 2, Fe plus 2, okay, Pb plus 2, add hydrogen plus 1, Cu plus 2, okay. Then after that there is Hg plus 2, Hg plus 2, Ag plus 1, okay, Au you can put plus 1, no problem, Pt plus 1, okay. These are the positive ions which are placed from top to bottom, from top to bottom. Are you getting it? I am drawing an arrow in the downward direction. These ions are placed from top to bottom, okay. Now these are the positive ions. What are these? These are the positively charged ions. Now there are another group of ions which are also there in the electrochemical series, which I'm writing them down on the screen over here. The first one is sulfate, nitrate, chloride, bromide, iodide, hydroxide. Now these are the negatively charged ions, and the negatively charged ions we know it is called anions. The positively charged ions we know they are called cations. Now this order which you see over here, cations carry positive charge, okay, anions carry negative charge. So this order you must memorize. This order you must memorize, and you will find this electrochemical series on page number 110, on page number 110 of your chemistry textbooks. Okay, so I have written the page number already on the screen. No need to turn your books for the moment. Just now you understand what I am speaking for you on the screen. Now what is the meaning of electrochemical series? Why the elements are arranged in, why the ions are arranged in this order? Let me explain that. Now the ions which are placed at the top, the ions which are placed at the top, these are what? These are reactive ions. These are what? Reactive ions. The ions at the top are reactive ions, and they will not discharge easily. Discharge means lose their charge. They prefer to remain charged only. But as you move from top to bottom in the group over here, as you move from top to bottom in this series, the ions which are placed at the bottom, they prefer to discharge. They prefer. They prefer to discharge. They prefer to discharge. The ions which are placed at the bottom, they prefer to discharge. Means what does this mean? They want to lose the charge and become neutral. Are you getting it? Because they are what? Less reactive. Am I clear? This is called electrochemical series, and you must learn this order by heart. You must learn this order by heart. There is a small correction over here. In the activity series of metals, sodium was above calcium, but here you have to learn above sodium is calcium. So this is the change which is slightly made. Okay. So potassium, then calcium, then sodium, then magnesium, then aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, and platinum. Okay.
Okay,
So please
see.
remember this order. Okay. This is already there on page number 110.
Yes, sir.
Okay. So I repeat this once more. The electrochemical series is a series of ions, cations, and anions which are arranged from top to bottom in the decreasing order of their reactivity or in the increasing order of their discharge. In the increasing order, if you move this way, the order of discharge is increasing, increasing, increasing order of their discharge. When I say discharge means to lose the charge and become neutral. Are you getting it? But the ions at the top, they don't want to discharge. They don't want to lose the charge. Okay. So that is the concept to be understood over here, because this concept is so important that without this concept you cannot proceed further in the chapter. Okay. Now let me go back to the previous slide. Okay. So that is the electrochemical series. After the electrochemical series, there is another point over here: selective discharge of ions. Selective discharge of ions is the preferential discharge of ions present in an electrolyte at the respective electrodes. Okay, this is called selective discharge of ions. You must learn this definition also. They will ask you direct questions in the form of definition, or in the form of fill in the blanks, or in the form of one word. Okay. Selective discharge of ions is called the preferential discharge of ions present in an electrolyte. That means if in an electrolytic solution there are two positively charged ions, so the ion which is placed lower in the electrochemical series, it will be preferred to discharge. Okay, that is called selective discharge of ions. Now, after that, the factors that influence the selective discharge of ions are the relative position of ions in the electrochemical series, which I've already explained you. Relative position, the ions the ions at the bottom, they prefer to discharge, but the ions at the top, they don't want to discharge. That is what to be understood over here. Concentration of ions in the electrolyte and nature of the electrode. These are the factors which you must remember. These are three factors over here. They will ask you direct questions. What are the factors influencing the selective discharge of ions? So you have to write. The first one is relative position of ions in the electrochemical series. The second one is concentration of ions in the electrolyte, and the third one is nature of the electrodes. Okay, so these are the three factors. Now let me explain the three factors one by one. Let me explain the three factors one by one for the selective discharge of ions. Okay, now please watch very carefully. Please watch very carefully. The first factor is called relative position of ions. Position of ions in electrochemical series. Let us take an electrolytic cell. A container containing a solution. And this solution is prepared by mixing, say, sodium chloride and copper sulfate, sodium chloride and copper sulfate solutions, okay, in water. Okay, now this electrolyte contains sodium chloride and copper sulfate solution. So you can see there are two salts. When I say two salts, the sodium chloride, when it is put in water, it will dissociate to give Na plus and Cl minus. The other salt, that is copper sulfate, if it is put in water, it will dissociate to give Cu plus 2 and SO4 minus 2. So these are the ions which are present in this electrolytic solution. Now what I do is, I will take two electrodes, two conducting rods, and connect them in this manner in this electrolytic solution. The electrodes are connected. The positive electrode, which is called anode, is definitely connected to a key, and then to a battery, like this. Okay, plus minus plus minus plus minus. And the other electrode, which is called cathode, this one, it is called cathode, it is connected to the negative terminal of the battery. Now, as I've already told you, that this electrolytic solution contains sodium ions, chloride ions, copper ions, and sulfate ions. So I'm going to write these ions down over here. The first one is sodium, the second one is chloride, the third one is copper Cu plus 2, the fourth one is sulfate SO4 minus 2. And since we have made a solution by dissolving them in water, this water is going to break down into H plus hydrogen and hydroxyl ions. So I'm going to write them also, H plus and OH minus. So these are the ions present in this electrolytic solution. Now when the switch is put on, current moves in this direction. Current flows in this direction. Electrons move in this direction. The current comes out from the positive terminal of the battery. Electrons come out from the negative terminal of the battery in this direction. That is how this electrode is positive electrode, and that is how this electrode is negative electrode. Now the ions start moving towards their respective electrodes. All the cations, what are the cations over here? The cations are sodium, the other one is copper
Copper,
and hydrogen.
hydrogen.
So the cations which are moving towards the cathode are sodium ion, copper ion, and hydrogen ion. Correct? These are the ions moving to the cathode. Now all the anions, that is chloride ion, sulfate ion, and hydroxyl ion, they will move to the anode. Am I clear? So I'm going to write them down. The ions moving to the anode are Cl minus, the other one is SO4 minus 2, and the other one is OH minus 1. Am I clear? Now I will ask you a question. Look at the cathode side. Among these three ions, sodium, copper, and hydrogen, please tell me which one is placed lowest in the electrochemical series. Among sodium, copper, and hydrogen, which one is placed lowest? Lowest? It is copper, correct. So among these three ions, copper is placed lowest, which means copper is the least reactive. That is why this copper ion at the cathode, it will discharge, it will lose its charge. Now how will this copper lose its charge? Cu plus 2. How will this copper lose its charge? What does it do? Look at the plus 2 charge over there. What does plus 2 charge mean? Indicate. Is it short of 2 electrons?
Loses.
It can't lose electrons.
Cu
plus 2 means what? It has to what?
It can lose.
No, not lose. It is a metallic
It can
ion.
lose.
No. It is not a
It
metal. It is a metallic ion. Cu plus 2 means it is short of how many electrons? It is short of how many electrons? Cu plus 2 means
two
it is short of 2
electrons.
electrons. Correct. Correct. So this Cu plus 2, the copper ion, this copper ion at the cathode, it will gain 2 electrons. It cannot lose. Copper metal ions, they gain electrons. So copper ion, it gains 2 electrons and becomes copper metal. It becomes copper metal, and then it
Yes.
sticks to the cathode. Remember this, very very important point. Cu plus 2 means copper ion. Cu, this plus 2 means it is short of 2 electrons. So it will take 2 electrons. It will take 2 electrons, accept 2 electrons and become copper metal. So this is discharge. So copper ion takes 2 electrons to become copper metal. Now what is the addition of electrons called?
Addition, reduction,
Yes.
reduction.
Yeah, it is called reduction. Very good. Who was that? Chevang?
Chewang Nima. Yes,
Yeah.
sir.
Addition of electrons is called reduction. What is that? It is called reduction. So
Reduction.
addition of electron is called what? What is it called?
Reduction.
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 All of you speak.
Reduction.
All of you speak. Addition of electron is called what?
Reduction.
It is called reduction.
Reduction.
Addition of electrons is called reduction. So I'll give you a nice word over here to remember. R-E-D, red cat. Have you seen a red cat?
Re-
Red cat.
No, sir.
Yes, sir.
No, no, sir.
Never mind. If you have
Red
not
cat.
seen, now you will see over here, red cat.
Yes.
This RED means what?
Re-
RED means reduction. RED means what? Reduction. Okay. And this
Reduction.
CAT means what?
Yes.
Reduction.
CAT means cathode.
Cathode.
At the
Cation.
cathode, at the cathode,
Okay.
at the cathode, reduction is happening. Reduction means gain of electron. Are you getting it? At the
Yes, yes.
cathode, reduction is happening. Gain of electron. Understood? No? This is an easier
Yes,
method
sir.
to remember. Am I clear? Am I clear, boys?
Yes,
Yes, sir.
Okay. Now
Yes,
come,
sir.
now come to the anode side. Come to the anode side. Come to the anode side. Now tell me, amongst chloride, sulfate and hydroxide in the electrochemical series, which is placed at the bottom? Which is placed at the bottom? Which is at the lowest?
Hydroxide.
It is what? Hydroxide. Very good.
Hydroxide.
Who was that? Aditya?
Hydroxide.
Yes, Aditya, no?
Yes, sir.
Yeah, very good.
Yes, sir.
Yes, sir.
So it is hydroxide which will discharge. At the anode, who will discharge? Hydroxide. Who will discharge? Hydroxide. Are you getting it? Please mute yourselves. Some of you are not muted. Please mute yourselves. At the anode, hydroxide will discharge. OH minus 1. What does OH minus 1 mean? How will it discharge?
It will discharge one electron.
It will lose one electron. Minus 1 electron.
Lose one electron.
Yes. Hydroxide, if it
Yes,
loses
sir.
1 electron, does it become hydroxide OH without the charge? Without the charge? Does it? If hydroxide ion loses 1 electron, it becomes OH only. Hydroxide. In this manner, if I take 4 hydroxide ions like this, another hydroxide ion, it will form another OH. I will take one more hydroxide ion, lose one more electron to become another OH. I take one more hydroxide ion, remove one more electron, it becomes one more OH. Now, why I am doing this 4 times is, now you see, mathematically if you add this, there are how many hydrogens total? Tell me. How many
Four.
hydrogens? 4. So this 4
Four.
hydrogens combine with 2 oxygen to give water molecule, and the remaining oxygen they combine with each other to form oxygen gas. Are you getting it? Are you getting this
Yes, sir.
technique? Are you getting this technique? Huh?
Yes, sir.
Are you sure?
Two, two, four, two.
See,
Yes, sir.
Just add the total. Hydrogen is 4, no? Hydrogen is 1, 2, 3,
Yes,
4.
sir.
Look at the
Yes,
total
sir.
of oxygen. 2 plus 2, 4, no? 1, 2, 3, 4. Am I clear? Am I clear now?
Yes, sir.
Yes, sir.
Okay, very good. Now, was there loss or gain of electrons at the anode?
Loss
Loss.
of electron.
There was loss of electron,
Loss.
no? Now, what is the meaning of loss
Yes,
of
sir.
electron in terms of
Yes.
oxidation reduction?
Oxidation.
Loss of electron means what?
Oxidation.
Oxidation, no?
Oxidation.
Loss of electron means what?
Yes, sir.
Oxidation. Now I'll give you one shortcut over
Oxidation.
here. I'll give you a shortcut over here. You have seen an ox. Have you seen an ox?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
An ox.
Yes, sir.
Remember an ox.
I know.
An ox.
And no.
An ox. Red cat. Red cat. An ox. N means what? Anode. OX means ox. Ox means what?
One.
Oxidation. Oxidation, no? So is this
Oxidation.
easier,
Yes,
no?
sir.
Is this
Yes,
easier
sir.
for you?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So did you understand the first
And no.
relative position of ions in ECS?
Yes, sir.
Okay. So
Yes,
this is
sir.
called preferential discharge of ions in this chapter, electrolysis. Okay. Am I clear, boys? Okay, good. Now
Yes,
just
sir.
hang on and look at the diagram very carefully. Hang on and look at the diagram very carefully and see what question you can ask. I'm waiting for somebody to ask me a question.
Sir.
Yes.
So how did H2O plus O2 came?
Where? Where?
So the H2H2O plus O2.
2H2O.
Yes,
2H2O.
sir. So how did it come?
Wait. Let me explain.
Yes, sir.
Wait.
Yes.
Wait, let me explain the next slide, okay? Wait. Look at the next slide. Can you see the next slide? On the anode side,
Yes, sir.
Yes, sir.
I told one hydroxide losing one electron to become hydroxide neutral, another hydroxide losing another electron to become second hydroxide, the third hydroxide losing one more electron to become third hydroxide, the last hydroxyl ion losing one more electron to become fourth hydroxide. No, if you add all this, I'm
Yes,
getting
Yes,
four
sir.
oxygen, no, plus four hydrogen, no.
yes, sir.
Yes, sir.
Am I getting
Yes,
four
sir.
oxygen and four
Yes, sir.
hydrogen? Now these four oxygen and four
Yes, sir.
hydrogen,
Yes, sir.
they must combine with themselves to form compounds, no. So the probable composition of the compound which is going to form is water molecule and oxygen molecule. Just check now. 2 to the 4. So 4 hydrogen done. Oxygen is
Yes,
2
Yes,
sir.
sir.
plus 2, 4. Now is it clear?
Yes, sir.
Is it clear now?
Yes, sir.
Who asked me the question?
Yes, sir.
Who asked me the question? Is it
Aditya.
clear?
Aditya.
Aditya, now it's clear?
Yes.
Aditya, is it clear?
Yes, sir.
Okay, good. It's good.
Yes, sir.
Okay. Okay. Now let us go to the next what you call point in the previous slide. Before going to the next point, there is a second factor influencing the selective discharge of ions, that is called concentration of ions in the electrolyte. It is called what? Concentration of ions in the electrolyte.
Concentration.
And the third one is nature of the electrodes. So this, now I think it is almost time. Okay, so these two factors I will explain
Yes,
in
sir.
the next class. Okay, am I clear? Am I clear?
Yes, sir.
sir.
So just hang on.
Yes, sir.
Yes, sir.
Let me take the final attendance before leaving the class. Okay, boys. Please hang on over there only.
Okay, sir.
Please hang on. Don't go away. Yes, Dakshis. Yes, Dakshis. Yes, Dakshis. Vinayak.
Vinayak's mic has been disabled.
Yes, automatically. Automatically,
Yes,
no?
sir.
Making a lot of noise. That's why.
Microphone.
Okay, now attendance is already taken. Okay. So now you can get ready for the next class.
Yes, sir.
Sure. Yes, sure.
Bye, sir.
Thank you, sir.